Welcome students. First two theories of failure we have discussed, that was maximum principal stress theory and maximum shear stress theory. The maximum principal stress theory we call that Rankine's theory, and the maximum shear stress theory Guest and Tresca's theory. Now after that we will move to the next theory of failure, that is maximum principal strain theory or maximum normal strain theory, and it was proposed by Saint Venant, therefore called as Saint Venant's theories of failure. According to this theory, it states that the yielding or failure at any point in a material begins when the maximum strain in the material exceeds the strain corresponding to that at yield point during tension test on UTM. Means if we compare with the first and second theory of failure, first theory of failure compared the principal stresses, second theory of failure compared with shear stresses. Now this theory of failure compares with strain in the material. You know what strain is? Deformation upon its original dimension. So deformation upon original dimension, that ratio we call as strain, you know very well. So as per this theory, yielding at any point in a multi-directional loaded stress system will occur when the strain at any point reaches or exceeds the strain while it was performed on UTM for tensile test. Okay, so let us consider that in a biaxial or triaxial state of stress where sigma 1 is greater than sigma 2 is greater than sigma 3, where sigma 1, 2 and 3 are the principal stresses, then we can write the strain in each direction, strain in sigma 1 direction, strain in sigma 2 direction, strain in sigma 3 direction. Let us write the strain in sigma 1 direction. That formula you already know from the strength of material basics, that epsilon 1 we denote as strain. 1 means in the direction of principal stress, 1 major principal stress is equal to sigma 1 upon E modulus of elasticity minus mu, that is Poisson's ratio, sigma 2 upon E minus mu sigma 3 upon E. And we know that the same strain at yield point while performing the tension test on UTM is nothing but sigma yt, and that sigma yt can be written as the strength upon factor of safety upon E. Therefore, similarly this strain is equal to stress upon modulus of elasticity E, so that can be written as SYT upon a factor of safety divided by E. Therefore, now according to this theory of failure, this value of epsilon 1, that is strain, if it becomes equal to the strain during tension test on UTM, so we can equate these two. Now according to this theory, this strain epsilon 1 is equal to sigma 1 upon E minus mu sigma 2 upon E minus mu sigma 3 upon E. When this value either reaches or exceeds that the strain we obtained while performing tension test on UTM, that is epsilon is equal to SYT upon E FOS, factor of safety. So if we simply equate it, we will get the condition of failure. So let us equate and see what we get. So we get here sigma 1 minus mu sigma 2 minus mu sigma 3 is equal to SYT upon factor of safety, because each term has its denominator as modulus of elasticity, that can be cancelled out. So for a triaxial state stress, we have the formula sigma 1 minus mu sigma 2 minus mu sigma 3 is equal to SYT upon a factor of safety. In a biaxial state system, this sigma 3 can be equated as 0, and then we get sigma 1 minus mu sigma 2 is equal to SYT upon factor of safety. Okay, and this SYT upon factor of safety is what? Nothing but sigma yp, means stress at yield point while performing the tension test. So the equation becomes sigma 1 minus mu sigma 2 is equal to sigma yp at yield point. From here we can have two cases. Earlier also we have seen the 4 quadrants, means sigma 1 sigma 2 can be both tensile, sigma 1 sigma 2 can be both compressive, one can be tensile, other can be compressive. That means the nature of sigma 1 and sigma 2 can differ. So in first and third quadrant, you must recall it, in first and third quadrant we have the sigma 1 and sigma 2 in same nature, that is both tensile or both compressive. And similarly in second and fourth quadrant we can have sigma 1 and sigma 2 of different nature, one tensile and other compressive. Let us see what happens when we see particular cases of these two types of, when the stresses are same and when the stresses are of different in nature. First of all, if sigma 1 and sigma 2 are same in nature, that is both tensile or both compressive, then we have the formula sigma 1 minus mu sigma 2 is equal to sigma yp. So if we take this minus mu sigma 2 to the right side, it becomes sigma 1 is equal to sigma yp plus mu sigma 2. If we see it very carefully, you will observe that this sigma 1 means major principal stress is becoming something greater than sigma yp. Sigma yp value is added some value, that is mu sigma 2. So sigma 1 is exceeding the limit of sigma yp. It means that in quadrant 1 and 3 the magnitude of stress at failure can be larger than sigma yp, that is sigma 1 is greater than sigma yp. So this was not a case in first and second theories of failure. So this is a new thing here. But this brings our attention to think that how can a stress value reach and exceed the value of sigma yp. So after sigma yp, after crossing the limit of sigma yp, the material is going to fail according to this equation. Now let us see the other case. If sigma 1 and sigma 2 are opposite in nature, that is one compressive and another tensile, then the formula sigma 1 minus mu sigma 2 can become sigma 1 plus mu sigma 2, and when it goes to the right hand side it becomes sigma 1 is equal to sigma yp minus mu sigma 2, because one is compressive, other is tensile, therefore signs will be plus and minus different. It means that this sigma 1 value is equal to less than sigma yp value, and less than by what factor? Mu sigma 2. And these things can be very clearly seen when we plot a graphical representation of this theories of failure, like we have done for the before that first and second theories of failure. So let us see the plot for this theory of failure, that is maximum principal strain theory of failure. Okay, now let us understand how the graph is plotted about this maximum principal strain theory. We know that in biaxial stress system we have the formula sigma 1 minus mu sigma 2 is equal to sigma at yield point. If sigma 1 minus mu sigma 2 becomes equal to sigma yp, then definitely the strain energy will the strain in the material will be high, and therefore when it becomes equal to that of the sigma yp, therefore the material will fail according to this theory. Now let us plot this in a graph. As in the case previous two plots, we have sigma 2 here, say this is sigma 1. Now to plot it, let us first mark that sigma yp range. The sigma yp range can be okay. This is the square as per principal stress theory. Now as we have seen that from here, if both are tensile or both are compressive, that means in the case of first and third quadrant, sigma 1 will be, this will go that side, it will become sigma yp plus this term. So definitely the sigma 1, the principal stress will be greater than sigma yp, By what factor? By this factor. So, whatever mu sigma 2 value will be there, that will be added to this portion. That means sigma 1 will become greater than sigma yp. But sigma 1 becoming greater than sigma yp means this is the square of sigma yp. So, sigma yp is at this place, this is sigma yp. This value is sigma yp for sigma 2, this is sigma yp, and this is also sigma yp. Now, see, since sigma 1 is becoming sigma 1 is equal to sigma yp plus this term, then definitely this will go out of this square region. So, the plot will be so, we can write the equation of each and every line. If you start to mark, say this is point number A, this is B, this is C, D, E, F, G and H point. We can write the equation of each and every line. It is very easy to write. See, if you see this only A, B region, you will see that it is away from this square. Away from this square means this region is, this is the sigma yp about what? On the line of sigma 2. So, this will be the equation of sigma 2 and it is above sigma yp, that means definitely sigma 2 minus mu sigma 1 is equal to plus sigma yp. Because here the sigma 2 region is above sigma yp, therefore, this value will go and add to sigma yp, and so sigma 2 value in this region will be higher. Similarly, if you want to write for this equation, for this line, it will be sigma 1. Why sigma 1? Because it is in the line of sigma 1, it is away from this sigma 1 square. So, sigma 1 minus mu sigma 2 is equal to plus sigma yp. Similarly, if we write in third quadrant, this will be, see, this is again away from sigma 1 line. So, it will be sigma 1 minus mu sigma 2, but this sigma yp is negative. So, it will be minus sigma yp. Similarly, this one is about sigma 2 in the line of sigma 2. So, it will be sigma 2 minus mu sigma 1 is equal to minus sigma yp. Why minus sigma yp? Because it is in the negative of the sigma 2 downward direction. Similarly, we can write other equations. This is less than. So, in second and fourth quadrant we see that it is within the square, and in first and third quadrant it is going away from the square. So, this region is, now this is sigma 2, so sigma 2, it is less. So, therefore, plus mu sigma 1 is equal to sigma yp. This is plus here, it will go this side and it will become minus. So, the value of sigma 2 will be less than sigma yp. Similarly, you can write here, it is related to sigma 1. So, sigma 1 plus mu sigma 2 is equal to sigma yp, but it is in the negative side, therefore, it will be minus. Similarly, you can write it for this line, this is the sigma 1 direction, so sigma 1, but it is less than sigma yp, therefore it will be plus mu sigma 2 is equal to plus sigma yp, y plus because it is in the right direction. Similarly, we can write for this line, this is sigma 2 plus mu sigma 1 is equal to minus sigma yp. The interesting thing to see from this theory of failure is that maximum principal stress theory was saying that the stress level, the maximum principal stress should not exceed the yield point level, yield point stress level. But here see, in the first and third quadrant, that means when both the stresses are tensile or both are compressive, in that case the principal stress is exceeding the yield point. That should not be there. So, it is exceeding the yield point region, yield stress region, but when the stresses are not same in nature, that is one is tensile, other is compressive or in the other way, then in that case it is failing much before reaching the yield point. Means it is not giving good result either in first and third quadrant nor in second and fourth quadrant, and that is why this theory of failure is not used in any type of materials, may be brittle or ductile, because see, if we use this theory of failure, then what the problem will be? The problem will be that we expect that the material should not, the material if stressed beyond sigma yp, it should fail, but it is saying that if material is stressed beyond sigma yp region also, it is not failing. So, that is not true. Similarly, the material is not reaching this sigma yp level, but before that also it can fail. So, when the stresses are same in nature, they are not breaking even after it is stressed above beyond sigma yp, but when the stresses are opposite in nature, then they are failing much before it is reaching the sigma yp value, and that is why this theory of failure is not used. Now, we have seen the plot was looking like this. It was like a rhombus or pyramid, where in first and third quadrant it is stressed out, and in second and fourth quadrant it is stressed inside, and therefore we have written the equation of each and every line. Here the value of SYT is marked on x and y axes, that is sigma 1 and sigma 2 axis. You can very clearly observe that in first quadrant it is going beyond sigma yp, we can say sigma yp or SYT, one and the same thing. It goes beyond sigma yp in third quadrant, and in first, second and fourth quadrant it is not even reaching the sigma yp, but the failure occurs. So, this theory of failure is not suitable for any type of material, that is brittle or ductile material, because it is very dangerous. It is very difficult to predict when the failure will occur, because at some point of time it is exceeding sigma yp, at some point of time it is before reaching the sigma yp also material is failing. So, this theory of failure is not used for any type of materials. In next lecture we will see the next theory of failure.